any number of such devices may be inserted or cut out. Still, it will be found that the regulation occurs. A constant current being maintained, while the electromotive force is varied with the number of the devices. The change of phase of the secondary current is simply a result following from the changes in resistance. And, though secondary reaction is always of more or less importance, yet the real cause of the regulation lies in the existence of the conditions above enumerated. It should be stated, however, that in the case of a machine the above remarks are to be restricted to the cases in which the machine is independently excited. If the excitation be effected by commutating the armature current, then the fixed position of the brushes makes any shifting of the neutral line of the utmost importance, and it may not be thought immodest of the writer to mention that, as far as records go, he seems to have been the first who has successfully regulated machines by providing a bridge connection between a point of the external circuit and the commutator by means of a third brush, the armature and field being properly proportioned, and the brushes placed in their determined positions. A constant current or constant potential resulted from the shifting of the diameter of commutation by the varying loads in connection with machines of such high frequencies. The condenser affords an especially interesting study. It is easy to raise the electromotive force of such a machine to 4 or 5 times the value by simply connecting the condenser to the circuit. And the writer has continually used the condenser for the purposes of regulation, as suggested by Blakesley in his book on alternate currents, in which he has treated the most frequently occurring condenser problems with exquisite simplicity and clearness. The high frequency allows the use of small capacities and renders investigation easy. But, although in most of the experiments, the result may be foretold, some phenomena observed seem at first curious.